Human intelligence, along with the advanced artificial systems we build to understand the world, never actually touch raw physical reality. Instead, reality reaches us through representations. We interact with measurements, derived datasets, flat images, and the text of scientific papers. Modern software operates even further from the source, extracting patterns exclusively from these abstracted layers, disconnected from the organic phenomena beneath. The public conversation often frames the crisis of the AI era as a simple battle of misinformation, a binary war between verified facts and deliberate lies. But information networks fail in many more ways than intentional deception. The deeper systemic vulnerability across our data architecture is the gradual erosion of truth attachment. Truth attachment is the continuous, auditable tether that binds a final conclusion back to its exact origin in the physical world. Discovery intelligence is designed to maintain this tether. It operates through an architectural mandate that prioritizes strict epistemic discipline over simple predictive optimization. Without that structural tether, predictive models are simply optimizing on detached illusions. Scientific discovery requires an intact chain to reality. Truth is not a static property of a single statement. It is a fragile, continuous chain of events. This diagram maps out the full 8-step sequence required for a physical event to eventually become a hardened belief: reality, observation, measurement, representation, transformation, interpretation, claim, and finally, belief. In the observation and measurement phases, human-designed instruments possess physical limits. Every sensor and protocol operates with specific error modes, selectively filtering out parts of reality from the very beginning. Moving through representation and transformation, the encoding of that data inevitably destroys granularity, surrounding context. By the interpretation and claim phases, the data is frequently asked to do too much. Conclusions are drawn that outrun the mathematical weight of the underlying evidence. Finally, in the belief phase, a confidence weight is assigned to the discrete assertion, cementing the process. We also have to account for the people operating this pipeline. The professional assumption that raw data enters the system in a neutral state ignores how the data was acquired. Pre-existing assumptions, institutional incentive pressures, and direct career risks dictate what targets are even selected for measurement in the first place. Evidence enters the pipeline from a human-shaped environment. We can call this the measurement ecology, the biased filter that determines what data is permitted to exist. If a graph, a generated label, or a statistical metric is severed from this long chain of origin conditions, it carries zero inherent meaning. Information decays organically, independent of deliberate deception or malicious actors. This node illustrates context collapse. Real, accurate data becomes misleading simply by having its surrounding environmental conditions and temporal meanings stripped away during processing. Then there is proxy drift, also known as Goodhart's Law. This occurs when a measurable indicator is relied upon so heavily that it is mistaken for the actual phenomenon we originally set out to study. And throughout the process, we encounter narrative compression. The messy, ambiguous reality of the physical world is overly simplified into a neat, confident story that ignores the hard limits of the evidence. Now introduce artificial intelligence into this already fragile ecosystem. Generative models drastically lower the cost of producing plausible representations. Text, complex images, and derived labels can now be fabricated instantly, at industrial scale. This massive volume of synthetic representation effectively breaks the human capacity for manual verification. We cannot review the pipeline fast enough to catch the decay. This saturation introduces a secondary, more insidious complexity, known as the liar's dividend. The liar's dividend occurs when the sheer ubiquity of synthetic media gives actors the cover they need to easily dismiss genuine, factual evidence as fake. Artificial intelligence scales and weaponizes representational drift. It turns systemic noise into a structural crisis, making hard-coded epistemic architecture a requirement for scientific survival. Because manual fact-checking cannot scale, discovery intelligence must be built as rigorous epistemic infrastructure. We have to apply a strict architectural doctrine to stabilize these erratic nodes. The first rule is that there can be no free-floating conclusions. Every claim generated by the system must be explicitly hard-linked back to an underlying evidence object. We enforce this with a provenance link requirement. Data lineage, who acquired it, when it was generated, and exactly how it was transformed must be structurally preserved in the software as a first-class object. Next is the context frame. Details like environmental conditions, testing protocols, and baselines cannot be treated as optional metadata. They must travel locked tightly to the data they describe. When conflicting evidence enters a single belief state, we apply the rule of contradiction. Opposing data must never be silently averaged away into a single clean score. It must be held separately in visible tension. True epistemic systems treat ambiguity, noise, and missing variables as required structural features, rather than weaknesses to hide behind smooth graphs. Implementing these precise objects forces the software to definitively separate raw fact from interpretive narrative, securing the entire chain of truth. The goal is not to build static answer machines. True scientific intelligence must be engineered to explicitly accommodate ongoing belief updates. Truth-seeking requires visible, mechanistic revision the exact moment new, verified evidence arrives. Zooming out to the societal level, the stakes are severe. Without this rigorous infrastructure, we risk losing the collective ability to maintain a stable relationship between our beliefs and physical reality. This defines the mission of discovery intelligence, to demand that factual grounding, transparent auditability, and epistemic honesty become the absolute baseline standards for scientific software. In an era of infinite representation and automated synthetic generation, epistemic architecture serves as the necessary structural foundation for systems claiming to pursue scientific truth.